Welcome to today's Explainer. We constantly look at these massive factories and the incredible products they crank out, but we almost always miss the absolutely clever engineering happening right under the surface. So today, we're bringing one of those hidden marvels to light, and we're going to break it down piece by piece. So how do industries efficiently transfer heat? It sounds like a simple physics question, right? But on an industrial scale, it's actually a massive puzzle. You've got these liquids and gases that need to be drastically heated up or cooled down, constantly, reliably, and here's the kicker, without ever mixing them together. To solve this, engineers rely on an absolutely ingenious solution. It's called the shell and tube heat exchanger. It's literally a workhorse of modern industry, and by the time we finish this explainer, you're going to understand exactly how it works.
All right, Section 1, Anatomy of the Exchanger, the four main parts. Basically, every single shell and tube heat exchanger boils down to four core components. We've got the header, the shell, the tubes, and the baffles. Now, this isn't just a parts list, it's the complete structural foundation of the machine. The interplay between these four exact pieces is what makes the whole thing function so perfectly. First up, we have the header. Think of this as the grand gateway for the machine. It's the dedicated entry and exit point for the fluid. And what's really brilliant about this design is that it can be easily opened up for cleaning and maintenance. When you're dealing with industrial fluids day in and day out, things get messy, right? Systems need to be serviced. So the header provides that necessary, practical access point to keep the whole exchanger alive and kicking.
Moving on to Section 2, Inside the Tubes, the Journey of a Drop.
Okay, let's think of our primary fluid as the protagonist of our story here. Step 1, the fluid enters through that header we just talked about. Step 2, it flows directly into the tubes, and then, and this is super important, it loops around. It doesn't just, flash in and flash out. That loop physically extends the amount of time the fluid spends inside the machine. Finally, step 3, after making its loop, the fluid exits right back out through the header. This clear, looping path gives the whole operation its continuous forward momentum.
Next up, Section 3, the shell and baffles surrounding the tubes.
Now, this is where the magic really happens. A second fluid flows into the massive outer shell surrounding those tubes. So you have the first fluid safely contained and looping inside the inner tubes, while an entirely separate second fluid just floods into the external chamber. The key takeaway here is that this second fluid completely and entirely surrounds those inner tubes. We've got two fluids intimately close to one another, but perfectly physically separated by metal walls.
But the secret to making this whole thing efficient lies in our final component, the baffles. See, the shell isn't just a big empty tank. The baffles act like strategic roadblocks. They guide that second fluid's flow, helping to transfer heat way more efficiently. They literally force the outer fluid to zigzag and weave as it travels through the shell. By actively directing this flow, the baffles ensure the second fluid maximizes its contact time with the inner tubes, which drastically drives up the efficiency of the entire heat transfer process.
When you put it all together, the brilliance of this operation becomes incredibly clear. On one hand, you have fluid 1, totally isolated, flowing inside the inner tubes, making its loop, and exiting. Simultaneously, fluid 2 floods that larger external shell, actively being guided and churned by the baffles. Seeing these two distinct paths working side by side really solidifies our understanding of the whole shebang. They work in perfect concert to exchange heat without ever physically mixing. It's awesome.
Which brings us to Section 4, Real-World Applications, Heating and Cooling.
This single system actually has incredible dual capabilities. Depending entirely on what you pump into that outer shell, you can use the exact same structural hardware to either dramatically heat up the fluid trapped inside the tubes, or conversely, drastically cool that fluid down. It's just an incredibly versatile workhorse for industrial processes. Let's see how this works in practice. So, if the goal is heating, high-temperature steam is passed through the outer shell. As that hot steam weaves through the baffles and totally surrounds the inner tubes, the heat aggressively transfers right through the metal walls. This actively warms the primary fluid that's safely circulating inside those inner tubes. It is a stunningly effective, completely non-mixing exchange of energy. Which leaves us with a pretty provocative question. How many of these hidden machines do you rely on every single day? From the power plants generating your electricity to the manufacturing of the everyday products you use, shell and tube heat exchangers are absolutely everywhere. They really are the invisible, brilliantly engineered heartbeat of modern industry. Thank you so much for joining me on this explainer, and I'll see you next time.